This module introduces the hardware specifications for ip-20c and ip-20c High Power R2 version. The agenda of this module will cover the following topics: physical dimensions comparison, available interfaces comparison, marketing models, how to recognize a product by the part number, power supply options, power over Ethernet injector specifications, antenna compatibility specifications, hardware architecture and logical block diagrams. Here's an overview of ip-20c radio specifications for both the classic and the high power version. Both are full outdoor Ethernet radio systems with dual carrier capabilities. The classic ip-20c has a frequency range from 6 to 42 GHz, while the high power version can work between 6 to 11 GHz. Adaptive coding and modulation is available for both and can operate between that can go from QPSK to 2048 QAM. Both support direct and remote mount installation options and channel bandwidths ranging from 3.5 to 80 MHz. Both can be placed in 8+0 configurations with 8 carriers aggregated to the same antenna and proprietary mediation devices. When installing an ip-20c, it is important to know what the physical dimensions are. The ip-20c's size is of 230 by 233 by 98 mm, while the high power version is 315 by 284 by 107 mm. The ip-20c has a max weight of 6.5 kg, while the high power version is 6.8 kg. The maximum power dissipation is 75 watts with both carriers active for the ip-20c and up to 135 watts for the 20c high power. Both can be mounted on a pole with diameter ranging from 8.89 cm to 11.43 cm. Now, let's have a look at the interfaces of the units. A front view of the ip-20c and its high-power counterpart reveals the two antenna ports. There is a different arrangement for the carriers, as you can observe in the presented technical drawings. For the ip-20c, carrier 1 is the one sitting below, next to the line interfaces, while for the ip-20c high power, the second carrier sits next to the line interface ports, below. A rear view instead will reveal similar configurations, even if the look is slightly different. The TNC source sharing interface is presented in both units. This port is dedicated for MIMO setups, which is the connection between both nodes on the same site, for synchronization of the voltage control oscillator and reduction of phase noise. The RSL interface, connected to the received signal level measuring mechanism, which is used during the antenna alignment, for easier alignment. The classical ip-20c version is running the voltage over a B and C connector, while 2 pins are used in the ip-20c high power version. The LEDs are also present, showing visual indications of current most important alarms. Both units present a handle for raising, hoisting and generally safely moving the network element. To the right side of the screen you can see the 2 iterations for the high power version, with the upper one for use with radio filters and the lower with a diplexer casing. Now, let's see what a bottom view of the node will reveal, from left to right. The power interface, for one single power input from a-48 volts DC current. Next, we have Ethernet interface 1, which can also power up the units with the power over Ethernet standard. Next in line, we have the second Ethernet interface, port 2, which is SFP type. Then, the Ethernet interface 3, which can also be ordered as data sharing in case you're using a MIMO setup. Finally, we have the management interface running over RJ45 interface. 2 labeling formats are available for ip-20c, as shown in the following figures on the left side of the screen. Except for the interface labeling, these versions are identical. I single version for the high power version, but this product has a choice of radio filters or duplexers to be installed with. Note in this table the naming convention for marketing model construction. Basically the name is made out of the name of the product, ip-20c, followed by the regional standard, then the frequency band, then the TX to RX separation and block indication, channel indication low, high or blank, TX low or high indication Ethernet ports options. Here, the EES in our example means electrical, SFP. ESX would have meant electrical, SFP and MIMO ready. Here are two examples of marketing model names. First example reveals an ip-20c dual-core, ETC standard, 15 GHz, TX to RX separation of 315 MHz, two identical duplexers covering channels 4 to 7, TX higher and the ports are electrical, SFP and extension port, which means MIMO hardware ready. The second example shows an ip-20c high power, in 11 GHz, with wide channel support, TX to RX separation of 500 MHz, with duplexers covering channels 4 to 9, TX is high and the ports are electrical, SFP, and the extension port for MIMO-ready hardware. When dealing with cables connectivity to the unit, note the following important aspects. All connectors are using the same IP68 compliant plastic gland, ensuring waterproofing. The plastic gland can accommodate Cat5 or Cat6 cables, DC and optical cable without a diameter from 7 to 9.5 millimeters. The outdoor Ethernet cable could be supplied ready for use or for crimping in the field. The outdoor optical cable is supplied ready for use in several lengths. This gland plug is supplied as default with the installation package. Regarding the power supply for the ip-20c standard, the unit is equipped with two options: direct DC connection from power source, proprietary power over Ethernet injector. There is no redundancy between them. A redundant power supply should be utilized. With the PoE solution, the total length of the cable between the ip-20c PoE port and the switch or router where the device is connected to should not exceed 100 meters. Also, in this scenario, the PoE injector should be installed in first 10 meters of the max 100 meters run. For the ip-20c high power version, only the DC power connection is available. There is no power over Ethernet capability for the power needed by this device. The PoE injector is an outdoor unit which can be mounted on a wall, pole, or indoor rack. Each PoE injector kit includes the following items: PoE injector, 2 DC power connectors, identical to the ones used for the ip-20c. 2 models of the PoE injector are available. One model which includes 2 DC power ports with power input ranges of ±18 to 60 volts each. Second model which includes 1 DC power port number 1, with a power input range of ±40 to 60 volts. The PoE injector has 4 interfaces, as follows: the power over Ethernet or PoE port, the gigabits Ethernet data port, that supports the 10100 base D standard. The DC power port 1 for ±18 to 60 volts or ±40 to 60 volts. The DC power port 2 for ±18 to 60 volts, optional. Regarding environmental requirements, ip-20c is compliant with international standards in all its aspects, like temperature, humidity and others. As an example, operationally speaking, ip-20c is compliant with ETC EN 300-01914 class 4.1, while for storage is compliant with ETC EN 300-01911 class 1.2. Shown here you can observe the temperature ranges tested for continuous operation and also for exceptional functionality with limited reliability. If you plan to order an antenna, note that Ceragon network elements work with following vendors: Comscope, former Andrew, RFS, Xian Putin and Radio Wave. Note also in the right table the waveguide and antenna flange codes and standards for each operating frequency band. The following diagram presents a detailed block diagram of the ip-20c. The ip-20c combines full system capabilities with a very compact form fit. The all-outdoor system architecture is designed around Ceragon's IP core components, enabling a true multi-core design. The next diagram presents a detailed block diagram of the ip-20c high-power version. As you can see, it is almost identical to the classic ip-20c, keeping full system capabilities with the same compact form fit. The all-outdoor system architecture presents the same multi-core design with the added options of using either transceivers or duplexers, marked in light blue and green to the right side of the diagram, just before the antenna connection. The module has covered the following topics: physical dimensions comparison, available interfaces comparison, marketing models, how to recognize the product by the part number, power supply options, power over Ethernet injector specifications, antenna compatibility specifications, hardware architecture and logical block diagrams. Thank you for your attention.